नाउ सभी को डर लग रहा है भाई, हाउ टू सॉल्व डिफिकल्ट ट्रिग्नोमेट्री, प्रूव दैट क्वेश्चंस. Trick number 1, convert everything into sine and cos. Suppose I have tan theta, I will write that as sine theta by cos theta. Now if I have cot theta, I will write that as cos theta by sine theta. Suppose I have cosec theta, I will write that as 1 by sine theta. And suppose if I have sec theta, I will write that as 1 by cos theta. Now the idea of this trick is to simplify the entire question into sine and cos form. Trick number 2, remember 3 identities as 9 forms. Suppose I have my first identity, sine square theta plus cos square theta is equal to 1. 1 plus tan square theta is equal to sec square theta. And identity number 3 is 1 plus cot square theta is equal to cosec square theta. Now I can write this in 2 more forms, which is 1 minus sine square theta equal to cos square theta, and 1 minus cos square theta is equal to sine square theta. Similarly, I can write sec square theta minus tan square theta is equal to 1, and sec square theta minus 1 is equal to tan square theta. For the third one, I can write 1 is equal to cosec square theta minus cot square theta. I can also write cot square theta is equal to cosec square theta minus 1. The third one, it's more like a tip than a trick. Look for algebraic identities hidden in the question. Suppose I have sin cube theta plus cos cube theta upon sin theta plus cos theta. Now the numerator is a cube plus b cube. I can write this as sin theta plus cos theta into sin square theta minus sin theta cos theta plus cos square theta upon sin theta plus cos theta. Now this and this gets cancelled. I have sin square theta minus cos square theta in the numerator upon sin theta plus cos theta. This is a square minus b square. I can write this as sin theta plus cos theta into sin theta minus cos theta upon sin theta plus cos theta. If I cut sin theta plus cos theta, after simplification, I am getting sin theta minus cos theta. Now, the second example, sin square theta plus 2 sin theta cos theta plus cos square theta in the numerator upon sin theta plus cos theta. If I adjust this numerator, it's nothing but sin theta plus cos theta का whole square upon sin theta plus cos theta. Now my bases are same. If I just reduce the powers after simplification, I am getting sin theta plus cos theta. Now trick number 4, important trigonometry adjustment patterns. Suppose you get this first pattern, sin square theta upon 1 minus cos theta, or cos square theta upon 1 minus sin theta. Look at this adjustment. Sin square theta can be written as 1 minus cos square theta upon 1 minus cos theta. Now I can expand the numerator as 1 plus cos theta into 1 minus cos theta upon 1 minus cos theta. 1 minus cos theta, 1 minus cos theta cut. After simplification, I am getting 1 plus cos theta. Similarly, cos square theta upon 1 minus sin theta, you can try this as 1 minus sin square theta upon 1 minus sin theta. This is 1 plus sin theta into 1 minus sin theta upon 1 minus sin theta. 1 minus sin theta, 1 minus sin theta cut. After simplification, I am getting 1 plus sin theta. Now for the second pattern, if I get this square root of 1 minus sin theta upon 1 plus sin theta, the conjugate of this we will multiply and divide. Now 1 minus sin theta into 1 minus sin theta is 1 minus sin theta का whole square upon 1 plus sin theta into 1 minus sin theta is 1 minus sin square theta. Numerator का square का root is 1 minus sin theta upon, can I write this as 1 minus sin square theta as cos square theta का square root. This is nothing but 1 minus sin theta upon cos theta. Similarly for this, you will just multiply and divide with इसका conjugate, which is 1 plus cos theta. Numerator I am getting 1 plus cos theta the whole square upon 1 minus cos theta into 1 plus cos theta is giving me 1 square minus cos square theta. If I solve this, numerator का square root is 1 plus cos theta upon this square root of 1 minus cos square theta. I can write this as sin square theta, and square root of sin square theta is sin theta. So 1 plus cos theta by sin theta. The fifth trick is, whenever you reach a dead end, check RHS final value. Now suppose they have given me this question, prove that sin theta minus 2 sin cube theta by 2 cos cube theta minus cos theta is equal to tan theta. I will take LHS equal to sin theta minus 2 sin cube theta upon 2 cos cube theta minus cos theta. Now since I need to make tan theta, can I take sin theta common? I am getting 1 minus 2 sin square theta upon, can I take cos theta common? अंदर बच रहा है 2 cos square theta minus 1. Now इसके आगे क्या करना है? It's pretty unclear. If I look at my RHS, guys देखो, this is nothing but tan theta. So ये जो चीज है, this everything should result in 1. So let's understand how can we do this. If I just write this as tan theta, now look at this, 1 minus 2 sin square theta. If I write 1 as sin square theta plus cos square theta minus 2 sin square theta upon, again I will write 1 as sin square theta plus cos square theta, I am getting 2 cos square theta minus sin square theta plus cos square theta. Now if I adjust this here, I am getting tan theta in bracket sin square theta plus cos square theta minus 2 sine square theta upon, I am getting 2 cos square theta minus sine square theta plus, not plus, minus cos square theta. Now this thing should amount to 1, तभी तो मेरा tan theta as my RHS आएगा. So if I write this tan theta sine square theta minus 2 sine square theta and cos square theta, can I write this as cos square theta minus sine square theta upon, अभी नीचे भी cos square theta minus sine square theta बनेगा. So ये cut because that was my understanding कि this entire thing should result in 1. So I'm getting tan theta which is equal to RHS. Hence proof. Now the next question is prove that cos A upon 1 minus sin A is equal to sec A plus tan A. Now if I take LHS as cos A upon 1 minus sin A. Now let's see इसके आगे क्या करना है, because my RHS में the term is 1 by cos A plus this is sin A by cos A, मतलब मुझे denominator में cos चाहिए. How can I make this as cos? तो इसमें the simple trick is if I just multiply and divide with the conjugate of this, which is 1 plus sin A, 1 minus sin A into 1 plus sin A is 1 minus sin square A, which is cos square A. So can I multiply and divide with 1 plus sin A upon 1 plus sin A? Does not change my original LHS. So cos A into 1 plus sin A, just write it as simple 2 different brackets upon 1 minus sin A into 1 plus sin A gives me 1 minus sin square A. Now this is nothing but cos square A. So cos A into 1 plus sin A upon cos square A. If I cut this and the power, I am getting this as 1 plus sin A upon cos A. Now I need to get sec A plus tan A. If I just separate these terms, 1 by cos A plus sin A by cos A. What is my 1 by cos A? It is nothing but sec A plus sin A by cos A is tan of A, which is my RHS, hence proved.
Solving problem the border, let's do notebook app together, the momentary doubt. I'm solving problems one beat at a time. ICSE math is a puzzle, and the solution is mine. And the solution is mine. And the solution is mine.